So we're working on this 1¼ inch steel bar repair, and if you haven't seen it yet, you can see this thing split right here. And I have a couple of concerns as I'm putting it back together. For one, I don't have the implement it comes off of, and there are some interesting holes that I think I need to maintain distance and alignment with. So my main concern is, as you take a look here, these holes, right? And some of them look like they were pretty snug fit. So I want to make sure that I keep the overall distance between those holes accurate so that this thing goes back together and it works as it was designed. Another thing that I'm worried about is distortion, because if we weld this from one side, that weld's going to shrink and this thing's going to banana on us. So the ideal weld joint would be what they call a double V groove, where we V out the top and then we V out the bottom, and you put one pass on and you flip it and you put the other pass on, and that kind of counterbalances that distortion. But unfortunately here, if you take a look at this bracket, I'm really not able to get in here and make a bevel on either side without, one, my torch running into here and potentially getting into that flange, which I really don't want to do if I don't have to. So in my mind, the next best thing, and something that was brought up several times in our collaborative discussions online, was to just go ahead and focus on a double bevel, which is where we're going to take this member, which is basically our free member. We're going to bevel it here, we're going to bevel it here. We're still going to do the same thing. We're going to weld on one side, we're going to flip it over, we're going to weld on the other side, and counterbalance that distortion. I think that's the next best thing. And the third thing I'm a little bit worried about, just because of the thickness of this material, is it's going to somewhat restrain the joint during cooling, which could potentially cause some unwanted cracking, because as that weld solidifies, it's going to have a tendency to pull, and if the restraint of the weight of this material holds it back, it's going to crack. So what I'm going to do to counteract that is I'm going to use some preheat, and we're going to try to maintain a 150 to 300 interpass temperature, right? So that we don't allow that weld to cool extremely fast. And that's also going to help us if there's a little bit of extra carbon in here, meaning above about 0.30%, putting it into the medium or even the high carbon range. I don't believe that's the case, but it could be. So by preheating, slowing the cooling rate, not restraining the joint, allowing it to move around a little bit, and working with distortion by welding around the neutral axis and using good practices, I think that we can do this successfully and hopefully keep it from turning into a banana. All right, we're in the middle of our unconventional repair. Because we have to maintain alignment of holes, and without knowing exactly what those dimensions are and not having the piece to fit things up and take measurements, we're kind of guessing. So I'm going to take this thing, and I did a single bevel at this point about half the way down through the material, maybe a little more than half. And that allowed me to keep the bottom intact so that I could put that thing right back up to where it broke, and now I know my dimension is good. I'm using this piece of C-channel right here behind us to hold our alignment this way, and that way we don't have any offsetting of the material. And then what I'm going to do is I'm going to get this thing welded, tacked and welded right here, and put the first joint in, or the first pass in. Then I'm going to flip it over, and I'm going to back grind into that bright metal and cut my bevel on the back side, so I'm ending up with two bevels. And then I'll put a pass there, flip it over, put a pass there. And again, we're trying to balance out the distortion. Now, what a perfect time to put the Lincoln 205 AC/DC TIG stick machine to the test. I've run it in TIG mode. I've been impressed with it. I haven't had a chance to run it in stick, and I think now I've got a reason to try it. This thing's 200 amps, so it's going to have all of what we need to burn an 1/8 inch 7018, so we're well within the amperage range. So we'll take a look at how smooth the arc is and how well it does for us. I'm pretty excited to see it. I just want to tell you one tip from experience. If you're working with one of these kind of TIG torches with a nylon cover and with a nylon braided hose, when you're stick welding, you're going to want to get that as far away from the welding process as possible, because if there's any sparks, slag, or molten metal that comes out of the process or drips off, it's going to land on here, and chances are it's going to cause you to have a leak. I've seen it before. I've seen it with water-cooled varieties where they all of a sudden just start spraying, and we weren't even using the torch at the time. So just a tip, get that torch out of the way and it'll make it last a heck of a lot longer. So this is our stick electrode holder. As you can see, it's still bundled up Comes in the package with the product. So when you buy this thing, you get a TIG stick kit all ready to go. I think it's going to work just fine for what we need it to do today. And I'm going to uncoil those leads so that we're running straight leads. Go ahead and plug it on in. Oh. Nope, they're going to make us reverse polarity. So something interesting about this, even though it's an AC/DC machine, they've got them labeled as negative and positive, and then TIG torch and stick electrode up here. So it must be that they want us to switch these around so that when we're running in stick mode, we are physically reversing the leads to be an electrode positive. On the other hand, some of the other units, when you flip them from TIG to stick, they automatically go to DC electrode positive. This one doesn't, so we're going to have to swap these things around. Otherwise, we might not get the arc characteristic that we're looking for. All right, so treat it as a positive negative, and go ahead and follow the instructions on the front. Make sure you got it hooked up correctly. All right, we should be good to go. Carrying on with this repair, what I have here is a couple of tubes of 7018 that I picked up at the local weld shop, and it's kind of a blessing in disguise, right? Normally you'd like to buy your electrode in a little bit bigger package. You can save some money if you buy in bulk. But I typically don't stick weld a lot. I do mostly MIG and TIG repairs. So in the occasion that I have to run some stick electrode, I basically just have what they would consider to be farmer's rod over on the shelf. So this is a little bit more serious. It's structural in terms of supporting a farm implement. So I went down and grabbed some new 7018 so we can use strong low hydrogen electrodes. In the event this does have a little bit of extra carbon into it, the 7018 is going to help us with hydrogen cracking or underbead cracking. And because I don't use this a ton, and low hydrogen electrodes should be kept in an oven, once I open them, I either use them or they're basically garbage or only used for non-critical applications. So in this case, having two tubes allows me to keep one open and one closed in case I don't need that much electrode. So buying your 7018 in smaller packages is a blessing in disguise because you don't have to keep an electrode oven, you don't have to keep the stuff dry. I only keep enough on hand to do the job I'm working on. And that's just me. Maybe you do things different. Okay, let's set up to stick weld with our Lincoln 205. We're going to go ahead and change over to DC stick, press to select, and then we can set our mode. So let's go ahead and see. We're in soft mode, which is for 7018, so we're all set up. That's what we're going to run. If you were to want to run 6010 and or 6011, something that needs a little bit more crisp arc, maybe a faster freezing puddle, then you would switch over to the 6010 or the crisp setting. All right, we'll save it. This says 80 amps, and when I'm stick welding, I usually use a rule of thumb of about 1 amp for every 1,000th of an inch diameter for the electrode. So in this case, we're going to be running an 1/8 inch electrode, and as a decimal, that's 0.125 or 125 thousandths of an inch thick. And in that case, this takes approximately 125 amps. And we could look it up, right? There's probably manufacturer recommendations we could go out and check, and there's probably a range, right, at which we could operate this, whether we're welding in the flat position, vertical position, overhead, or some other odd combination, right? So what I usually do, if I'm welding 7018s, I like to be in that 120 range if I can get away with it. This is substantial material. It's thick enough to handle that much current, so I think we can do it, and this will ensure some decent penetration. If I'm welding thinner material or if I'm welding out of position, I'm going to turn that current down. It's going to give me a little bit more control. And remember, as you're going vertical, especially vertical up, that heat's rising with you. So you don't need as hot of an arc often to achieve the same penetration and profile. All right, I can see on the front panel of the machine, it's got a little voltage with an output arrow that tells me the output is on. So when I make contact to this thing, it's going to light off. You see I got my work clamp connected right here to the part, right here in the area that I cleaned, so that it's close by. We don't have to worry about grounding long ways or arc marking through the part. All right, let's go ahead and tack it. Good deal. We got her tacked on both sides, and I'm just gonna let it cool down a little bit. We'll chip away the slag, give it a little wire brush, and if it's looking good, I'm gonna make them tacks just a little bit bigger, and then we're gonna cut our bevel on the backside. Now, normally, if I can get away with it, I don't like to tack with 7018. I'd much rather tack with a 6010 or a 6011 because it's got a thinner flux, and at the end, it doesn't scab over like a 7018. So when we're working with this electrode, you wanna use it for tacking. You gotta kind of break the crust off the end of the electrode to expose the bare metal again so that it'll start the way that you want it to on your restart. All right, overall the tacks look good. I got a little more substantial tack on the side closest to me. I don't think that's going anywhere. I do notice a hell of a big Hershey's Kiss there, which we tend to call unloading. Not sure if it's because of the electrode or maybe because something was erratic in terms of the arc length, but that can happen from time to time. I'm gonna get that out of there. I'm gonna put a little more substantial tack on the first side that I did just to make sure that doesn't go anywhere, because when we pick this thing up, the sheer weight alone is gonna make it wanna break those tacks. Once I get that done and I'm convinced that we're in good shape, then we're going to cut that back bevel and we're going to get back to welding it. All right, let's talk distortion. Distortion happens in the direction of travel. So if we're welding along on a joint, in front of the weld bead, because the weld behind it is shrinking, it tends to pull apart the material as you're traveling along. So one way to counteract that is called backstep welding. And what we're going to do is a combination of that. I put my biggest tack right over here at the side closest to me, and we've got a small tack here just maintaining alignment. What I'm going to do is I'm going to weld the last inch of this in that same direction, and where's it going to try to distort? Out in front of me where there's no weld. And then behind me, what it actually does is as that weld shrinks, is it's going to clamp that and pull together, and we're going to use that distortion to actually help maintain or force more joint alignment right there at the end. So let's see if it works, but that's my approach. All right, we got that last inch of weld in there, and like I'm saying, what should happen now due to the physics of how that arc is shrinking, it should pull everything behind the weld on my side actually tighter together. Now, it can only pull it as tight as that tack's going to allow it to move on the other side, but even the residual forces are pulling in the right direction now. It's pulling towards itself instead of trying to pull away. And that's what we're going for. We're trying to make sure that this thing has everything going for it, so that it can get back in service and perform the way it was intended. Now I'm going to clean that out. I'm going to chip it away. I'm going to feather into my tack, and I'm going to put one solid bead all the way across here. I decided not to move it while it was tacked. And what I can do is once I have this on, then I can flip it over. I can cut my back bevel and grind into good solid metal. And at that point, I'll be ready to put that second root pass or that backside pass on. We're at a preheat of about 185 right now, a couple inches away from the weld. So we're just going to keep slowly bringing it up in temperature. All right, so as you can see here, we are at right about a 300 degree preheat. It's saying 280. I just had 300 a minute ago, I swear. And over on this side too, we were in that 300 degree range. So we're between 200 and 300. If I can get on this thing while it's still warm, we should be in great shape. Then like I say, we're gonna flip it over. We're gonna cut our bevel on the back side, and then we'll be able to go to town over there. Nice. All right. Here's that weld we just put in right there. Nice smooth bead all the way across. Looked like we had good fusion tying into both sides. We're going to go ahead and let this thing cool down just a little bit to make sure we're in that 150 degree interpass temperature range. Plus, it's going to be a lot easier to handle than when it's up over 300. Then we'll go ahead and get that backside prepped, and we will go to town. All right, so let's talk distortion. You see we just put that one pass in, and the ends wanted to lift up. Again, because that weld down here right in this area is shrinking, and it's pulling up on both sides. You can be able to see it over here as well, right? And I didn't clamp it on purpose. One, it's really hard to restrain and resist distortion on something like this. And we're trying to see if welding on one side and welding then on the back side helps to balance out the distortion, because in theory, it should. So I've ground the back side. We're ready to put a pass in, overlap the base metal. And I checked our interpass temperature is about 160 degrees, so we are in the ballpark. We're running 120 amps, 1/8 inch 7018. We're going to go ahead and burn it in there. Sweet. Pass number 2 in the books. All right. After that second pass, a little bit of cooling off during the grinding period, we are up over 220, I believe, on our interpass temperature. So we're going to go ahead and let that calm back down and cool down to about 150. And then we're going to flip it over and we're going to put another pass on the back side. All right, we flipped it over. We've ground down into bright metal into the back side of that other weld again, just to make sure we have good overlap in the root area. Our interpass temperature is down below 180, so we are approaching weld time. We're going to go ahead and put another one in and see what happens. Okie dokie. Gonna flip it over, gonna put 2 passes on the backside. All right, so you can see here, if we look down underneath the member, we've got some camber. This thing has lifted up because the first pass went in on the side that's currently down. So right now we've ground down back into good metal. I'm gonna put 2 passes in here right now, and then we're just gonna let it sit and we're gonna watch this thing pull itself back flat, right? I hope. Let's see. All right, so I think we're ready to rock. Let the electrode do the work, burn at its own pace. If it's burning off too slow, turn it up a little. If it's burning off too fast, turn it down a little. But ultimately, if you're dragging that electrode or moving it, you're probably going to have skips and voids in your weld. So best is to let it burn at its own rate. Okay, so I'm running this Weldmark rod today, or a Weldmark electrode. It says it should be ran between 105 and 155 amps. I'm in the 120 amp range, so I am in the sweet spot of that thing. And I gotta tell you, this is some of the worst peel in 7018 I've ever used in my life. I know there's multiple formulations. Some of it peels easier than others. And it could just be that I'm down there in that groove right now, and kind of like a nasty sub-arc weld, you need a needle scaler to get it out. But I'll tell you, I can't wait till I get up a little bit in this groove, and hopefully this slag starts to come off a little bit easier, because it's a pain in the ass, man. All right, so I've had a chance to try out this little Lincoln V205 AC/DC TIG stick welder in stick mode today. I've run 4 or 5 electrodes down about that far, welding across our little repair project here, and overall it's performing real well. I'll tell you, every machine has kind of its nuances, and once you get used to the arc starts and how this thing likes to operate, right? Whether that arc length likes to be a little longer, a little shorter, where the arc settles down at. And once you figure that out, this thing's welds pretty smooth. So I'm impressed. I'm gonna keep on running it, and hopefully it gets us through this job. So far, so good. Oh, and just in case you're wondering, this is a great example of how steel doesn't take as much current to weld as aluminum. If we were welding on 1 1/4 inch aluminum, we'd have to have a bigger machine to overcome the thermal conductivity of the material, or else it would never form a puddle. You'd just be essentially heating it with an electric arc. In the case of steel, it's not a great conductor, and we're welding 1 1/4 inch steel with 120 amps, albeit with stick electrode. Take it or leave it. It is what it is, right? On the other hand, if we wanted to switch over and TIG weld this, and I cranked it all the way to 205, I'm guessing that once we got rocking and rolling, we'd be laying a bead of about 1/4 to 3/8 of an inch wide, which is all you want to carry under a TIG arc. Seriously, folks, some of the worst slag that you can imagine trying to come out of there. Ultimately, hit it with a grinder, got it out. The weld underneath looks great, so that's a good thing. It's not anything wrong with the flux. It's just not one of them easy peeling formulas, like I say, and or having it down in there and that root kind of wedged it in there. So we're going to check interpass again. Let's see. Yeah, we're at about 180. About 180. So we're ready to put another pass in right on top of that one, and what we're hoping for, that's going to draw that other side back flat, right? Okay, let's do it. All right, now that we got that pass in there, what I'm going to go ahead and do is I'm going to let this thing sit and cool down, and I want to see what it does in terms of distortion so that I know what move to make next. Because ultimately I have a plan in my head, but we have to respond the way the metal is behaving. And even though we think we know what it's going to do, we really don't until we see it. And that's kind of one of the things that I like about repairs, right? It makes it interesting. You have to be spontaneous, and you got to kind of think on the fly based on how the situation is going. So we'll be back after a while after this thing cools down, and my hope is that we're right back where we want to be. All right, we put 2 passes on this thing with E7018 yesterday, and we let it cool down to room temperature real slow. I wanted to see what was going to happen and where this thing was going to end up. And we've got a little bit of camber to it, a little bit of bowing there. So what I'm going to do is we flipped it over just like we predicted, put a couple of passes on the back side, and we're going to watch that drop down, and hopefully that distortion is going to pull this thing back in the flat direction. Okay, so we're going to warm it back up here as we start so that we're maintaining our preheat and interpass temperature. Again, pretty heavy stuff, so we want to make sure everything's working for us. The last thing I want to do is have to make a repair of my repair or do it over again. So best practices is the way to go. And a rosebud would probably be better here. But yeah, I think it's still packed for moving. Yeah, the rosebud. I'm looking for it. So I'm sure it'll show up right after this job's done. So in the meantime, we're gonna use our cutting tip, and we're just not gonna touch that lever. Keep the heat moving. When we're doing a preheat, we're not typically going right up next to the joint alone. We're going to take several measurements up to 2 to 3 inches away from the joint. I'm going to try to get this in between 150 and 300. All right, we're feeling the heat coming off. Let's take a probe here. We're at about 200, so we got a little ways to go. Just nice even heat, letting it soak in. We definitely don't want to get it too hot, but we want to make sure it's warm and that we keep going in the direction we started. So our preheat's back up to 300 degrees Fahrenheit. We're gonna kick on our Lincoln Square Wave 205. There we go. And the only thing I can hope today is the slag starts chipping off this 7018 a little bit better. So far have not been impressed with the charcoal nature of the slag. A lot of times when you're welding with 7018, you get a slag that looks like a glass and it comes off pretty easy. This has a charcoal appearance to it, so it's a little bit different, but and it's certainly, the weld looks fine underneath of it. It just does not like to come off. All right, let's rock and roll. Rock on. And what you saw me doing there is oscillating side to side. I wouldn't really call it a weave. more of an oscillation where I'm not leaving the puddle. We're just basically touching top toe, bottom toe of what comes out to really look like a fillet weld as I'm stacking that next layer in there. And I don't know if you can see this or not, but we got up out of that groove a little bit. We got a little bit less of an angle, and now that flux is starting to self-peel. So maybe it was just the fact that we were so far down in that groove that it was pinching that slag in, which can happen, right? A lot of times on sub-arc. So we're moving in the right direction. I think boom, boom, boom. This is our last fill pass here. Then we'll be able to cap this thing right across. Should come out looking pretty darn good. Again, what we're going to do is just keep balancing out the weld. We're not going to weld too much on this side before we flip this thing over and weld again on the back side. All right, we still like our interpass temperature. We're under 300 degrees. We're going to rock in another pass. I'm going to try to overlap it by about 50 to 60%. Overlap the previous bead, that is, so that we've got nice fill going across here without a lot of valleys and voids. Let's see if we can do it. All right, definitely went in there nice. I can already see the slag peeling, so we're going in the right direction. Let this cool down a bit. We'll chip it off with our chipping hammer. We'll hit it with a wire brush, and then we'll go ahead and check our interpass before we put that final fill pass in on this side. Now I wish I had a time lapse here so that we could watch this thing drop. It's already come down about 50% as I put those two passes in there. So distortion or welding about the neutral axis is pulling that thing back flat. So everybody who said double bevel and double V-groove, right on the money. So here we are after our second fill pass. You can see we got good overlap in there. We got a nice stack, got a good spot there for our final bead. And as I'm looking underneath this thing, folks, it's pulled itself back down and it's flat again. So we're doing good. We're going to put the last pass in now that our interpass is down around 150, and then we'll flip it over and do the other side again. Now this is how that slag ought to just peel right off. So as we're working our way out of this groove, things are really coming together. A lot easier to work with when that slag just comes right off like that. Perfect. So now we flipped the part over. It's pulled itself pretty much back flat. It's really, really looking good. And I'm going to put a fill pass in on this side, and then we're going to go ahead and check it, see where we're at, get it cleaned up, and decide where to go next. All right, say what you want about stick welding, but there's just something hypnotizing about that arc just tick-tocking away, isn't there? Well, slag isn't peeling yet on this one, so we must be down in that groove just a little bit too tight. We'll let her cool down, we'll chip her, see what it looks like. That slag's peeling right off there. Looking good. Looking good. That's what we like to see. Nice and easy. And a nice flat contour, nice tie-in with that plate edge right there. So I'm happy with how it's turning out. Okay, we got our next pass in there. The slag is just peeling itself right away, so things are going good on this side. We still had a little camber to it, so I'm thinking this pass is going to pull it even more back flat. And I'm going to take a look at it and decide if we're going to put a third pass on, which should just about get us across here. Or if we're going to have to flip it over and put a pass on the backside first. All right, I am liking how those beads are laying in there, right? You can see here the first pass transitioned over the corner of the plate, nice. A little bit of work to do here at the end. I could have used some runoff tabs. Then I would have had to figure out how to cut them off, but that would have put our crater way on out here, and we would have had a more smooth transition at the corner. The second pass overlapped the first by more than 60%, so that basically looks like one bead right there, but it's two stacked over each other. And that's going to give us a nice flat contour and a good transition without a lot of reinforcement here. So we should have a full pen weld. It should be full strength, and get this thing back on the implement, back doing work. Well, here we are after that last pass. Again, we're looking real good here as we come across and we overlap that previous bead. We've got just enough room in here to get our final cap pass on. A little bit of work down here at the end, but I've been using this piece of channel iron to start up against, and it's really given me some good support. So had I done that over on the other side here, it might have turned out just a little bit better, but nothing that we can't fix right at the end of the job. Okay, our interpass temp is good. We are almost flat, but not quite, so I'm going to put this next pass right on here now, and we are going to see what we get. Cool! Look at that slag peel right off. Good deal. Now for the big reveal here. Look at that. Nice tie-in. It's a little bit fat over here on the end, but all in all, I think we're good. We don't have any areas of underfill. I don't see any incomplete fusion. That looks good. All right, we flipped our part over. Our interpass is just below 200. So we're going to try to fill this in because I don't know if we're going to be able to cap it. We got a little bit too much fill to put in there before we're ready. Put our work clamp back on the part. Make sure we got some contact there. We're ready to rock. All right, that slag wants to peel. It wants to, but can it? Let's see. Nope. So we got the slag out of there. We put our last couple of passes in. As you can see here, I turned the corner and actually welded right over the crater and filled it in on that last pass. So we were all good, and when I took a look, this thing had pulled itself back flat.